I'd have to go this.
Hey Tyler, I missed you.
Yeah, it's been a while.
Yeah. So welcome to the pre-class video on acid and bases. We're starting a new chapter.
Oh, nice. Okay.
Okay, so today all I want to do is talk a little bit about some terminology and remind you of a few things.
Okay.
And maybe introduce something a little bit new. And so here I've written up on the board a typical acid-base reaction. We have our acid HA reacting with our base B to form A- and BH. So, what is an acid? What did the acid do here?
Well, it looks like it gave its proton to the base.
Yeah, it gave its proton to the base as well as the charge on the proton, right? So an acid is a hydrogen donor, hydrogen ion donor, or we say a proton donor because H plus is just a bare proton.
Just a proton.
And the base is a proton acceptor. It accepted that H plus.
Right.
And it forms a nice little bond there. Well, that's nothing new. But what is maybe new is that in the first semester when you learn about acid bases, most of the time we just drew a single arrow.
Right.
But now we know all about equilibrium. And so we're going to talk about acid-base reactions as equilibrium reactions. So I could have written this backwards, right? I could have written this BH plus A minus goes to HA plus B.
Right.
Okay, so this is just the same reaction written backwards. Well, if it transferred a proton going forwards, it also transfers a proton going backwards.
Right.
So what's the acid here?
Well, the acid here would be what's donating the proton, so it would be B.
Yeah, the BH plus gives up its proton, ends up as B. The A minus accepts the proton, ends up as HA. Right? So if we look back at this first reaction again, the HA, it starts out as an acid, it donates its proton, what's left behind can act as
A base.
a base. Exactly. And so they're really tied together. So it's kind of cool. And you're going to learn about the terms that we use to talk about that. I'm not going to get there yet. One of the other things you're going to be doing is trying to recognize acids and bases that maybe you've never seen before. If you know, you're shown a chemical reaction, how can you tell what's an acid, what's a base? And so we want to look at another example. And so I've written up a reaction, and I know what these chemicals are, but I bet you Tyler's never seen them before.
I'll bet you I haven't either, because I haven't.
Because you haven't. So, but I bet you could figure out which one of these is acting as an acid and which one is acting as a base.
Sure, I mean, let's go to our basic understanding of acids and bases and know that the acid's going to be donating the proton. So if we look, there's an H13 over here, but this compound becomes H12 on this side. So it looks like it lost a proton.
Yep.
And sure enough, there's H7 here and H6 here. So it tells us that this gained that proton. So that means this would be acting as the base, that would be acting as the acid.
Yeah. So you don't even have to know what the compounds are to be able to figure out what's an acid and what's a base if you are given the formula.
Right.
Okay? So a couple other things you're going to learn about. You're going to learn about something called autoionization. What is it? Autoionization.
I know, like automobiles,
Right.
automatic.
Automatic, maybe automatic. Autoionization means that a molecule just automatically ionizes.
Right.
Right? And so here water is autoionizing. It's taking its parts and splitting it apart into ions.
All on its own. Just
All the time. In water, we think of as a covalent molecule.
Right.
The hydrogen-oxygen bond is a covalent bond. But to a very, very small percent, that water molecule will actually split up into ions, H plus and OH minus. Right? So is water an acid or a base?
I don't know, I think it's both.
It's both. It's giving up an H plus, but it's also giving up an OH minus, which is a base. Right? In a pure water solution, how many OHs do you get for each H plus?
One.
It's a 1-to-1 ratio, and say they're kind of balanced out.
Right.
And in pure water, they're there in very, very small quantities because this is an equilibrium reaction, and it's so important that it has its own symbol for the equilibrium constant. Kw equals H plus times OH minus. And why don't I put water in the Kw?
Well, your Kw is for aqueous compound, and your water is a liquid.
It's a pure liquid, so I really should have put little AQs over here. I'm getting a little sloppy there. Right? Pure liquid doesn't appear, and the value of that equilibrium constant is 10 to the minus 14. And you will have that memorized very shortly because you use it over and over again. Kw, 10 to the minus 14. The last thing we're going to learn about in class is pH. You've heard of pH. Some of you probably know what pH is. It's really how we measure the acidity of a solution. We talk about its pH.
Or its basicity.
Or its basicity, and we can actually talk about something called pOH.
Oh.
And pH is going to be related to the concentration of H+.
Right. And because H plus is acid, the more H plus it has, the more acidic it's going to be.
Yep. Okay, so, and you'll hopefully know why we use this funny thing, pH, instead of just talking about H plus concentration.
Right.
Actually, kind of makes sense.
Makes life a lot easier.
Yep. So, I think that's about it for today.
They're all set?
Yep, I think you're all set. We'll see you in class.